All right, let's get right into it. We're going to tackle a really fundamental question in AI today. When an artificial intelligence has to find one right answer in like a massive sea of possibilities, how does it even know where to start looking? This is the core dilemma, really, between two big strategies, what we call uninformed and informed search.
And you see this everywhere. Think about it. Your GPS finding the fastest way home through crazy traffic? That's a search problem. A bad guy in a video game hunting you down on a map? Yep, that's a search problem too. Even a streaming service digging through millions of movies to find the one you'll actually like, it's all about searching for that needle in a haystack. But, and this is the key, not all searches are created equal. So, to make this whole thing crystal clear, let's just use a simple analogy. Imagine you're dropped into a brand new city you've never been to before. Your mission? Find a specific landmark. You've really only got two ways you can go about this.
Okay, approach number one, you could be what we'll call the blind explorer. You just start walking, right? Systematically going down every single street until you finally, hopefully, stumble upon your destination. Or there's approach number two. You could be the smart guide. You'd use a map, maybe ask a local for a quick tip, or look for signs. You'd use clues to make an educated guess about which way to go. And boom, right there, those two approaches perfectly capture the difference we're talking about today.
All right, so let's dig into that first method, uninformed search. This is our blind explorer strategy. And you know, it's powerful in its own way, but, well, as the name kind of gives away, it's not exactly the sharpest tool in the shed. So, uninformed search, people often just call it brute force. It operates with literally zero extra information. The algorithm knows where it's starting, it knows what the goal is, and it knows what the legal moves it can make. That's it. No map, no guide, no hints. Its strategy is painfully simple. Check everything.
Let's make this real with a classic example you might have heard of, the traveling salesman problem. The goal is simple, right? Start in one city, visit a few others, let's say 4 more, and then get back home using the shortest possible route. Now, an uninformed search algorithm would tackle this by calculating the length of every single possible route.
Now, with just 5 cities, the number of different routes you can take is 24. Okay, that's totally manageable, right? The computer can just crunch through all 24 options and it'll find the absolute best one, guaranteed. But what happens when the problem gets just a little bit bigger?
And this right here is the single greatest strength of uninformed search. Because it checks every single option, it is absolutely 100% guaranteed to find the optimal solution. Not just a good one, the perfect one, every single time.
But, and this is a huge but, that guarantee comes at a staggering cost. Let's take a more complex problem, like a 24 puzzle. The number of possible states the algorithm might have to check can skyrocket to 10 to the power of 24. I mean, that is a number so ridiculously huge, it's practically impossible to compute. The time, the memory, it all just blows up exponentially.
So, to wrap this part up, uninformed search algorithms, and you might know some of these, like depth-first or breadth-first search, they promise perfection. But they are incredibly slow and they hog resources like crazy, which makes them pretty much impractical for a lot of big real-world problems.
Okay, so now let's switch gears and look at our second approach, informed search. If uninformed search is the blind explorer, then informed search is the smart guide who, well, they've got a trick up their sleeve.
And that secret trick, it's something called a heuristic. A heuristic is basically just a rule of thumb. It's an educated guess. It gives the algorithm a hint, a little nugget of extra info that helps it decide which path is more likely to be the right one. It's the difference between wandering aimlessly and, looking at a map and at least heading in the general direction of where you want to go.
But here's the catch, and honestly, this is the most important trade-off you need to get. The moment you start using these educated guesses, you lose the guarantee. You are no longer guaranteed to find the absolute, perfect solution. You have to make a compromise.
So what do you get for giving up that perfection? Speed. A lot of speed. Informed search gives you a good enough solution, but it does it in a tiny fraction of the time. I mean, think about a self-driving car that needs to swerve to avoid something. It needs a really good decision right now, not the absolute mathematically perfect decision 5 minutes from now, right? That's where this method absolutely shines.
So the key traits here are pretty clear. Algorithms like, say, A-star search or best-first search, they use these heuristics to just slash the time and complexity. They're quick, they're efficient, and that's what makes them perfect for solving those huge problems that would completely cripple an uninformed search.
Okay, so we've met our two contenders. Now let's put them head-to-head and see exactly how they stack up.
And this comparison really just lays it all out. On the uninformed side, you've got zero prior knowledge, so it's forced to check everything. But the payoff is that you are guaranteed the perfect, optimal solution. On the other side, you've got informed search, which uses those clever heuristics, those rules of thumb. But it means you have to compromise on that perfect answer. And this choice, it directly impacts complexity and speed. Uninformed is super complex and slow. Informed is way more efficient and much, much quicker.
So after all that, what's the big takeaway? What's the one thing to remember? Well, it all boils down to one of the most classic dilemmas, not just in engineering, but kind of in life too.
See, the choice between these two isn't about which one is just better. It's always about the specific problem you're trying to solve. You have to ask, do I need the absolute flawless perfect answer no matter how long it takes? Or do I need a fast, pretty good answer right this second?
And that just perfectly illustrates a much bigger question that we all face, right? Whether you're coding in AI or just making decisions in your own life, we are constantly making this choice. So I'll leave you with this to chew on. When is good enough not just okay, but actually better than perfect?